Welcome to the deep dive. This is where we take all that information you send our way, articles, notes, research, and really dig in. We want to get you up to speed fast, maybe share some surprising stuff, and hopefully have a bit of fun doing it. Today, we're tackling something called ComfyUI. It seems to be really changing the game for how people work with generative AI. We have a mix of sources, official docs, GitHub details, release notes, community chatter, all the good stuff. Yeah. So our mission today, what is ComfyUI? What's special about it? What kind of creative things can you actually, make with it? And importantly, how to get started. The core idea sounds pretty cool, taking complex AI models, linking them together visually, almost like building blocks, but without any coding. That's the promise we're going to explore. Okay, let's unpack this.
So based on everything we looked at, ComfyUI is essentially two things: a node-based interface and an inference engine underneath. And it's built specifically for generative AI.
Node-based meaning visual, like a flowchart.
Exactly. Instead of code, you've got this graph, these nodes you connect. That visual approach is really its defining feature. It's what makes it stand out.
And it's a main job.
It's really designed to let users build and run pretty advanced AI pipelines. Think Stable Diffusion, but with lots of custom steps. You visually connect different AI models, different operations, build your own workflow.
Right. Building complex chains.
Yeah, the sources really emphasize that modularity. You can swap parts in and out easily. And it's fully open source, runs on your own machine.
That local aspect is huge for control, privacy, speed too, probably.
Definitely. And while lots of people use it for images, that's common, the sources are clear. It's more versatile. It can handle workflows for video, for audio, even some 3D stuff is mentioned.
Okay, so that visual node interface.
Yeah.
That's the core difference. Let's get into why. Why build things this way? What are the actual, practical upsides?
Well, this is where it gets really interesting. That node system, that graph, it basically lets you design incredibly complex workflows without needing to be a programmer.
So things that might take hours to script, someone could potentially just click and drag together.
Pretty much. The sources mention examples like setting up a hires fix pipeline or doing advanced area composition where different prompts affect different parts of an image. You can see the whole process.
And seeing it must make it easier to figure out if something goes wrong, right? To debug.
Yeah, that's a benefit. And there are performance advantages too. The docs talk about a few key optimizations.
Oh? Like what?
Well, there's an asynchronous queue system, which helps keep things moving smoothly if you're generating multiple things. But maybe more importantly for experimenting, it's smart about rerunning things. It only re-executes the parts of your node graph that have actually changed since the last run.
Oh, hold on. So if I have a 5-step process and I only tweak the text prompt at the end, it doesn't rerun steps 1 through 4.
Exactly. It just recalculates from the point of change onwards. That can be a massive time saver when you're iterating.
I bet that speeds things up a lot.
It does. And it also has some clever memory management built in. This lets it run, apparently, even on GPUs with really low VRAM. The sources mention as low as 1 gigabyte for something.
1 gigabyte. Seriously, for diffusion models, that's really low.
It is. It really opens the door for people who don't have the latest, most powerful graphics cards, lets them experiment on maybe older hardware they already have.
That makes it way more accessible.
Absolutely. And apparently you can even run it without a GPU at all using a HEPU flag, though the source is warn it's very slow. You'd need patience.
Yeah, I can imagine. Okay, any other unique benefits to this visual, file-focused way of working?
Yes, and this is actually a really powerful one for sharing and reproducibility. The sources highlight this feature where you can save the entire workflow.
Oh, node graph.
Yeah, all the settings the models use, even the random seed number, all saved directly into the metadata of the output file, like inside the PNG image itself or a WebP or even FLAC audio files.
Wait, really? So if I make something cool, I can just send you the final image file?
And I can load that image file into my ComfyUI, and it instantly reconstructs the exact node setup you used to create it.
Wow. Okay, that's fantastic for sharing techniques or just understanding how someone got a specific result.
Exactly. It's not just sharing the picture, it's sharing the recipe. You can also save and load these workflows as plain JSON files too, which is more standard.
Okay, understanding the what and the why of the node system is clear, but what kind of stuff can you actually make? What models does it handle?
The range is really broad. That's a key point in the sources. It handles, well, pretty much all the Stable Diffusion variants you'd expect. SD1.x, SD2.x, SDXL.
The big ones.
Right. And newer stuff, too, like Stable Cascade.
Yeah.
And it mentions support for SD3 and 3.5, Flex, Lumina Image. quite a list.
So models you might already have from other tools would probably work. And you said it wasn't just images.
Correct. It's positioned as a general engine. For video, it supports models like SVD, Stable Video Diffusion, LTX Video, others are mentioned. For audio, Stable Audio, AC Step, even 3D, Hunyuan 3D 2.0 is listed.
Impressive versatility. Does it handle all the extra bits people use to fine-tune results, like
Yeah.
LoRa's and control nets?
It does. It loads the main model files, second PTs and safe tensors, but also VAEs, CLIP models, embeddings, textual inversion. Yes, LoRa's, hypernetworks, and critically, things like ControlNet and T2I adapters for guiding the generation.
And upscalers, too?
Yep, upscale models like ESR-Gen types, SwinIR, Swin2SR are supported. It really covers the waterfront for customizing your output.
And are there, like, starter kits, pre-made workflows or tutorials?
Yes, absolutely. The sources mentioned that's a big help for getting started. There are examples for common tasks, in-painting, out-painting, upscaling, using LoRa's, using ControlNet, but also more creative, complex things like generating video from text or an image, the 3D stuff. The website and wiki apparently show off specific examples like turning line art into a 3D style render or making those wild liquid collision videos. It shows the potential when you start chaining these nodes.
Okay, so chaining nodes is key. How does that actually look in the interface? What are some of the essential node types you'd use? Not all of them, but the main building blocks.
Right, thinking about building a basic image generation flow,
Yeah.
you'd start with loader nodes. That's how you bring your AI models into the graph.
Like loading ingredients?
Exactly. You'd have a checkpoint loader for your main Stable Diffusion model, maybe a LoRa loader if you're using one, a ControlNet loader, a VAE loader, those kinds of things.
Got it. Load the models.
Yeah.
Then what? Need to handle the image itself.
Precisely. You need nodes for image data.
Yeah.
Things like load image if you're starting with an existing picture, save image for the output, of course, and then manipulation nodes, image scale to resize, image crop, image blend, even specialized ones like image pad for outpainting if you want to generate content outside the original image boundaries.
Makes sense. And AI image generation often works in that latent space, right? That compressed representation.
It does. So you need nodes to bridge between the pixels you see and that latent space the model actually computes in. That's where the VAE encode mode comes in. It takes an image to latent space, and VAE decode brings it back from latent space to a visible image.
Encode and decode.
Got it. And you can manipulate things directly in latent space too with nodes like latent upscale or latent composite.
Okay, what about the text prompts? How do they plug into this visual system?
Good question. Your text prompts usually go into a node like CLIP text encode. This node takes your words and turns them into conditioning data.
Conditioning. That's what guides the AI.
Exactly. It tells the diffusion model what to generate. And the sources mention some neat tricks you can use right in the prompt node text, like using parentheses to add emphasis to certain words or curly braces for creating dynamic variations in your prompts automatically.
Dynamic prompts built right in. That's handy. Can you manipulate that conditioning data too after the text encode?
You bet. There are nodes for that. Like conditioning set area lets you tell the AI that a certain part of your prompt should only apply to a specific region of the image.
Ah, like a cat wearing a hat, but only apply wearing a hat to the cat's head area.
Kind of like that, yeah. Or apply ControlNet, where the conditioning isn't from text, but from something like a depth map or a human pose skeleton image.
Okay, connecting different kinds of guidance. And how do you see what you're making as you go?
Use a preview image node. You can stick those anywhere in the graph to see the intermediate or final results. The sources also mention an option for faster, lower quality previews using special TAESD models, which help speed up tweaking.
Right, faster previews for quick checks.
Mm-hmm.
Okay, this visual building sounds powerful, but how easy is it to actually, get it installed and running? What kind of computer do you need?
The sources list a few ways to get started. Probably the easiest, especially if you're on Windows with an NVIDIA card, is the Windows Portable package.
Portable package?
Sure. Yeah, you just download a zip file, extract it, and run the executable. No complex installation needed. There's also a more polished desktop application available for both Windows and macOS.
Okay, that lowers the barrier significantly. What about other setups? Linux, AMD, or Intel graphics? Apple Silicon.
For those, there's the manual install option. It involves using Git to grab the code from GitHub and installing Python stuff. But the good news is ComfyUI is designed to work on lots of different hardware, NVIDIA GPUs using CUA, obviously, but also AMD GPUs using ROCm or DirectML, Intel GPUs using their drivers, and even Apple Silicon Mac.
Wow, okay, so it's not just NVIDIA lock.
No, pretty broad support.
Yeah.
The sources recommend using Python version 3.12 currently.
That wide hardware support plus the low VRAM capability seems like a big deal for accessibility.
It really is. And another practical thing the sources mention, if you already use another tool, like Automatic 1111's WebUI, and have gigabytes of models downloaded.
Yeah, you don't want to download them all again.
Right. ComfyUI lets you point it to your existing model folders. There's a configuration file, extramodelpaths.yaml, where you just list the paths to your current tech points, LoRi's, control nets, etc.
Oh, excellent. That saves a ton of disk space and download time. Just reuse what you have.
Exactly.
So once you've got it installed, where do you go? For help? For learning those complex workflows? It's open source, so there's a community, right?
Absolutely. And the community and the resources available are a huge part of ComfyUI's strength based on what we read.
What are the key places to check out?
The official website, comfy.org, is the main hub. From there, you can find links to the official documentation and the ComfyUI wiki, although the sources do note these are works in progress, constantly being updated.
Okay, docs and wiki, where does the code live?
The main code repository is on GitHub under Comfy Anonymous ComfyUI. That's where the core development happens.
Comfy Anonymous, right?
Yes. And the sources also mention a related GitHub organization called ComfyOrg. This hosts other important projects like ComfyUI Frontend, that's the repository for the visual interface itself, which actually gets updated more frequently than the core engine.
Oh, so the interface and the backend engine are developed somewhat separately?
Kind of. There are also repositories there for the desktop app builders, the documentation source, and technical proposals called RFCs. It shows a structured development process.
How do updates work then with these different parts?
Generally, the core engine aims for weekly, stable releases. The desktop application usually bundles that stable core, but the front end, in its separate repo, might get updated daily with UI tweaks or features. And apparently, you can even tell your local ComfyUI install to pull the very latest front-end code directly from GitHub using a command line flag if you want bleeding-edge UI updates between the main releases.
That's cool flexibility. Stable core, but potentially newer UI if you want it. And you can track all this on the GitHub releases page and see who's contributing.
Exactly. It shows it's a very active project. And a really important part of the ecosystem mentioned in the wiki is custom nodes.
Custom nodes.
Yeah, plugins, essentially. The community creates tons of these custom nodes that add new functionalities, support new models, integrate external tools. It massively extends what ComfyUI can do out of the box.
Ah, so the community really builds on top of the core system. That's powerful. What if someone doesn't have the right hardware or just prefers not to install stuff locally? Are there cloud options?
Yes, the sources do list several cloud platforms and services where you can run ComfyUI workflows online. Names like Run Comfy, Comfy Deploy, Comfy Online, others were mentioned, so you can access it without a local install.
Good to have options. And for learning curve, the wiki has tutorials.
It does. It mentions sections for basic, advanced, and even expert tutorials, plus an FAQ. Those seem like great places to start learning how to build things or understand workflows others have shared.
Okay, let's try and wrap this up.
Sure. So bringing it all together, what we're seeing from these sources is that ComfyUI is a really potent tool. It's flexible, it's modular, aimed at anyone wanting to get deeper into generative AI workflows.
And that visual node-based interface seems to be the killer feature, right?
Right.
Offering deep control, customization, but without demanding coding skills.
Exactly. It sort of demystifies these complex AI processes. Instead of just code, you see the steps, you can connect them, tweak them visually.
Makes it more like a hands-on laboratory.
Yeah. And with support for so many models, flexibility on hardware, and this really active open source community churning out resources, tutorials, and those custom nodes, it feels very accessible and constantly evolving.
So we definitely encourage you, the listener, to check out those official resources, comfy.org, the wiki, the community channels, see the examples, maybe download a workflow and start playing.
So here's the thought to leave you with. What happens when you stop seeing AI generation as a black box or just a text prompt and a generate button? What possibilities open up for your creative work when you can actually see the entire pipeline, loading models, conditioning data, manipulating latents, upscaling laid out like building blocks that you can rearrange and experiment with? How might that change how you approach creating with AI? It's something to think about.